NASA has just confirmed the existence of the closest black hole to Earth ever recorded. Located only 1,500 light-years away, it's right in our cosmic neighborhood. But what does that really mean? Are we in danger? In this video, you'll understand why this discovery is drawing so much attention, and whether we should be worried or not. The closest black hole to Earth has been found in the constellation Ophiuchus, a region of the sky visible in the northern hemisphere, also known as the Serpent Bearer. It is located approximately 1,500 light-years from Earth. To give you an idea, this is the shortest distance ever recorded between a black hole and our planet. In astronomical terms, 1,500 light-years is practically just around the corner. This places the black hole within what scientists call Earth's cosmic backyard, a region relatively close to our solar system when considering the vastness of the Milky Way, which spans over 100,000 light-years in diameter. This discovery is making scientists rethink the actual number of black holes that might be scattered throughout our galaxy, especially those that are invisible, silent, and extremely difficult to detect. After all, if one of these objects went unnoticed for so long so close to us, how many more could be out there? The closest black hole to Earth wasn't seen directly, and that's what makes it so impressive. Unlike active black holes, which emit radiation as they consume surrounding matter, this one is completely silent. It doesn't shine, emit light, or produce any obvious signals. It's a dormant black hole, virtually invisible. So how did scientists find it? The answer lies in its companion star. This black hole is part of a binary system, meaning it's dancing together with a normal star. Astronomers noticed that the star was moving in a strange way, as if it were being pulled by something invisible, something with enormous mass that couldn't be seen in any wavelength. Using powerful telescopes and spectroscopic techniques, scientists analyzed the light from the star and calculated its orbital motion. The only possible explanation was that it was orbiting an extremely massive and invisible object, a black hole. This discovery was made possible thanks to international collaboration among astronomers and the use of advanced instruments like the Very Large Telescope, VLT, in Chile. What makes this finding even more important is that it shows dormant black holes might be hiding very close to us, and we can only detect them by observing the effects they cause around them, like true cosmic ghosts. The discovery of this black hole near Earth is more than just an astronomical curiosity. It's a game-changer in how we understand the universe around us. First, because it's a dormant black hole, a type that emits no light or detectable radiation. This means it wasn't consuming matter at the time of observation, making it virtually undetectable by traditional methods. The only reason we found it was due to the gravitational effect it exerts on the nearby star. This kind of black hole is considered a cosmic ghost. It's there, but no one can see it. Second, its proximity to Earth is a wake-up call for astronomers. If we found one this close now, how many other silent black holes might be hiding even closer? This discovery suggests that the total number of black holes in our galaxy could be far greater than previously estimated. Moreover, this finding reinforces the idea that black holes aren't just star-devouring monsters lurking at the centers of galaxies. They can be part of stable binary systems, coexisting with normal stars for billions of years, without causing any disturbance.
Finally, this discovery paves the way for a new era in astrophysics, the hunt for invisible black holes.
Scientists now know where and how to look. And the more we find, the better we'll understand galaxy formation, stellar evolution, and the future of the universe. This newly discovered black hole is classified as a stellar black hole, meaning it was formed from the explosion and collapse of a massive star that reached the end of its life. And even though it's considered small compared to the supermassive black holes that reside at the centers of galaxies, it's still an absolutely colossal structure. According to scientists' estimates, it has about 10 times the mass of our Sun. That means it's incredibly dense. All that mass is compressed into a region only a few kilometers in radius. For comparison, imagine fitting the weight of 10 suns into a space the size of a small city. The result is an extreme curvature in space-time, as if the universe forms a bottomless pit around it. Visually, the black hole itself cannot be seen, but its event horizon, the boundary beyond which not even light can escape, marks the limit of its gravitational power. Anything that crosses that line is lost forever. What's most fascinating is that, despite its immense mass, it manages to orbit peacefully with a companion star without consuming it. This happens because the system is in a stable configuration and the black hole isn't actively pulling in material. This quiet relationship between a black hole and a living star offers valuable clues about the evolution of binary systems, and about what might happen to stars like our Sun in the future, although our star is destined for a very different fate. This is, without a doubt, the question that comes to mind most when we hear, a black hole is closer to Earth than ever before. But the answer is no, it poses absolutely no danger to us, at least based on what science knows so far. Even though it might sound scary, this black hole is about 1,500 light-years away. In practical terms, that's an extremely safe distance. For comparison, the closest star to our solar system, Proxima Centauri, is just over 4 light-years away. In other words, this black hole is nearly 400 times farther than that star. Moreover, it's part of a stable system, orbiting a companion star without causing any major disturbance. It's not moving toward Earth, it's not consuming matter uncontrollably, and there's no indication that it's about to change its behavior. Another important point is the very nature of gravity. A black hole's gravitational pull doesn't magically spread across space. It follows the same rules as ordinary gravity. Unless Earth were to move directly into its path, which is not going to happen, there's no risk of us being sucked in. So while this discovery is fascinating and maybe even a little unsettling, there's no reason to panic. Instead, it serves as a powerful reminder that we live in a mysterious universe, full of invisible forces and silent giants, and that we still have much to learn about them. This is one of the most intriguing aspects of the discovery. The black hole is completely dormant. In other words, it isn't feeding on matter, isn't emitting radiation, and isn't releasing energy. It's silent.
Invisible. Létal.
And that makes it even more terrifying. But what exactly does a dormant black hole mean? Active black holes are those that consume matter from their surroundings, gas, dust, even stars. When this happens, they release an enormous amount of energy, especially in the form of X-rays. This radiation can be detected by special telescopes, making it possible to find and study the black hole. Dormant black holes, on the other hand, are like predators lying in wait. They emit no signals. They simply exist, exerting extreme gravity without visibly interacting with their environment. That's the case with the black hole discovered in the constellation Ophiuchus. It's in a kind of resting state, orbiting a companion star without siphoning off its matter. This condition makes the discovery even more impressive. After all, it's like finding a ghost in the dark. It was only revealed thanks to the movement of the star around it, which exposed the presence of an invisible and massive companion. And the most unsettling part, if we were able to detect a dormant black hole this close to us now, how many more could be hiding in the darkness of the universe, right under our noses? Before this discovery, the title of closest black hole to Earth belonged to V616 Monocerotis, also known as A0620-00, located about 3,000 light-years away. It's also part of a binary system and was discovered thanks to the radiation it emitted while feeding on its companion star. In other words, it was an active black hole, which made it easier to detect. The new discovery, just 1,500 light-years away, has cut that distance in half and marked the beginning of a new era in astronomy, the era of invisible black holes. Until now, astronomers believed it was possible to map most nearby black holes based on the signals they emit. But this new case changes everything. It shows that black holes might be much closer than we thought, simply hidden by their silent, dormant nature. Another interesting example is Gaia BH1, discovered in 2022, also located about 1,560 light-years from Earth, practically tied with this new candidate. However, the difference lies in the level of evidence and the detection methods used. The most recent one has such peculiar characteristics and is so camouflaged that it has become one of the most mysterious and challenging cases ever recorded. These comparisons reinforce a chilling idea. We may be surrounded by silent black holes, invisible to our eyes and instruments, quietly orbiting ordinary stars without giving off any obvious signs of their presence. And if the closest one is 1,500 light-years away, who's to say there isn't another at 1,000? Or even 500? This discovery changes a lot, and not just the star maps. It shakes the foundations of modern astronomy and reopens questions we once thought were settled. First, it challenges traditional models of how we detect black holes. For decades, astronomers relied mainly on radiation, especially X-rays, to find these objects. But this new black hole, completely dormant and invisible, doesn't follow the rules. It shows us that there is a hidden zoo of black holes silently orbiting, invisible to all our eyes and sensors. Second, it reinforces the importance of indirect detection methods, such as precisely monitoring companion stars. The star orbiting this black hole moves in a strange way, as if being pulled by something we can't see. It's like discovering a thief by the movement of the curtains, without ever seeing the intruder. This could usher in a new era of stellar archaeology, where scientists hunt for gravitational traces to uncover hidden monsters. Third, and perhaps most unsettling, this discovery forces us to face an uncomfortable reality. We know far less about the universe than we'd like to admit. If a black hole of this size, relatively nearby, went unnoticed for so long, how many more are out there? How many are orbiting harmless-looking stars, completely camouflaged in space-time? Finally, there's an inevitable philosophical impact. This discovery reminds us that the universe was not made to be easily understood. It is vast, strange, often silent, and under no obligation to explain its secrets to us.